right, so today we'll still look at the basic elements of programming, even though you've started writing some program. And then if there's enough time, we'll look at input and output. So we started talking about the basic elements of programming. We talked about the comments. We said the comments are there to explain what the program is doing. We talked about some basic constructs as well. Okay. So there's also the special symbols. The special symbols, the special symbols are symbols like the mathematical symbols or operators and other symbols that you'll see when you are writing your program. So for instance, there's the addition, subtraction, multiplication, and then division. Division is the /. Okay, so anytime you are writing a mathematical expression in your program, C++ program, and use the /, it means division. The asterisk here means multiplication. Okay, then we come to the second row. The second row is made up of some punctuation marks. Okay, so we have the dot, call this the dot operator. You'll see what it's used for, mostly used in functions. We have the semicolon. The semicolon is used to terminate a statement, okay, or to show the end of a C++ statement. So anytime you write a statement, you end with a semicolon. And we have the question mark. Okay, the question mark also, which is used or can be used in your program. We have the comma as well. Okay, then when we come to the third row, we have what we call the relational operators. We saw that from the algorithm lecture. So the less than or equal to, not equal to, equal to. Okay, so these are used for relational purposes, for conditional expressions. Okay. Then we have what we call reserved words. Reserved words. Okay. Now all these are considered to be tokens. Okay, I'll not go much into it. At this level, at your top-up level, you learn what we call compiler design. Okay, and in that particular topic, they'll break it down. What that topic does is it breaks down, takes a code in a particular language, maybe C++, and then breaks it down into the phases that you go through when you run a code. Okay, so one of the phases is what we call, or the first phase of compilation is what we call the lexical analysis. Okay, so what it's going to do is that the compiler will scan all your code written and then pick out the tokens. Okay, so one of the tokens, we have the symbols. Another token is what we call the reserved words. Okay, then we have other tokens as data types and so on. Okay. So this technique is what is also used in tokenization. It's also what is used in AI today. Okay, so if you see the way they are developing a lot of AIs for maybe learning languages or helping, or what we call the AI assistants, okay, like Siri, like Google, what's it called? Google Assistant, and so other Alexa and so on, and even ChatGPT and some of these tools that we use. Okay, they all follow these constructs of tokens. Okay, so it's something that going forward you begin to appreciate in computing or in programming. Okay. So what are these keywords? These keywords are basically words that are reserved in your program. Okay. Every programming language has what we call keywords. Okay. There are some that will be similar. Maybe you go to Java, you go to Python, you see some of these words, similar words in your programming language. Okay, so some of these words, especially the data types, okay, they are all considered to be key words or reserved words. Example, int, float, double, char, cons, void, return, and so on. Okay. Sorry. Now, if you go to the last page of your lecture notes, I've given a list of, okay, sorry, I think I'm using a different document. Okay, so if you go to the last page of your lecture notes, you'll see most of the um, keywords or reserved words listed there. Okay, and I've placed them in categories. Okay, just a moment, let me locate the updated lecture notes so we can follow from what I'm talking about. All right, so just before that, there's also an image there which uh, so the lecture notes is the handout, and so the one as in Dennis. So this is some of the images from the flowcharts. So those who were in class last week and you use the, what's it called, the draw.io, okay, I'm sure you will identify some of these symbols in there and what they do. Okay, so here are some examples of the keywords. So the keywords that falls under data types, you have int, float, double, char, bool, void. Keywords that fall under flow control, you have if, else, switch case, default, for, while, do, break, continue, return. Keywords that fall under modifiers. Okay, so you'll be seeing some of this as we go along. That's the signed, unsigned, short, long, conscious, static, volatile, okay, keywords such as that comes under object and this class, struct, union, enum, okay, a whole lot of them. Okay, there are some we might not use at this level, but as we go on with maybe other programming language, you see them, especially for example, exception handling. Okay, namespace, keyword, namespace and using. You've seen that we started using this namespace keywords already. There are others like type definition, type def, templates, mutable, explicit, and so on. Okay, so these are all examples of keywords in C++ programming or in the C++ programming language. All right. So let's move on from the keywords and let's look at identifiers. Identifiers. Okay, so identifiers are also a third category of tokens. Okay, so identifiers basically means names that are given to entities in your program or things that appear in the program. Okay, so identifiers come in the form of variable names, come in the form of constant, come in the form of function name, and so many other examples that we'll see as we go along. Okay, so an identifier, for instance, let's take a variable name. Okay, so these are containers, okay, which store value. Okay, so I believe we've all done mathematics before, and you are given a problem to solve, and you say, let x be equal to this, or let y be this. Okay, so that letter x there is a variable. Okay, so the same way when you're writing a program, you represent a memory location or a particular location in memory by a variable. Okay, and we call that declaring a variable. So it says C++ identifier consists of letters, digits, and underscore. Okay, so mostly your variables are made up of letters, digits, and underscore. Okay, now for the underscore, it is used to separate your variable. Okay, so we'll look at the example shortly. Then we have what we call identifiers. Some identifiers are predefined. Okay, if we say something is predefined in programming, it means that it's already built into that language. It already exists within that language. Okay, so you don't have to define it again. Okay, so example of this predefined identifiers is the cout. Okay, and I've told you what the cout does. The cout is used to output your data. So cout is a predefined identifier, but num, okay, or num, maybe the person is using number or something, is user defined. Okay. So your identifier can be predefined or it can be user defined. If it's user defined, that means that you look at your problem and then you, the programmer, decide on which variable name to use. Okay, so if you saw the example we did some weeks back when we were looking at these sequential algorithms, okay, so where we looked at the to find what's it called um, the simple interest, to find maybe area of a circle and so on. Okay, we defined when we looked at the input and output variables. What we did was that we defined the variable names ourselves. Okay, whether to use x or to use number one or to use num. Okay, we define it ourselves. Let's look at some legal identifiers in C++. Okay, so for instance, the word first, okay, is a legal identifier, so you can use it as an identifier. Then, for instance, another one here, it says first name. First name, okay, so first name is a legal identifier. Now, someone will ask, why didn't we write it as first? Sorry. At first, and then leave a space and then write name. Okay, we'll talk about the rule shortly. Okay, so this over here is wrong. Okay, now in writing your variable names or identifiers, you do not space them. You do not space them. Don't leave a space. Okay, so over here, you don't space it. Okay, you either write it together, for instance, first name, okay, the naming construct, if there are maybe more than two words, typically the second word should probably start with a capital letter, okay, in that form. So you can write it this way, which is correct, or you can also say first underscore name. Okay, but when you leave a space between it, it will give you an error. Okay, so this is what we mean by using this the underscore. Okay. Now another example here is conversion. Another example here is pay rate. So you can see the way it's written pay rate. Pay is one word, rate is another word. But after writing the first word pay, the second word, which is rate, it starts with a capital letter. Okay. And then we have also counter one. Okay. Now it says in our definition that we can use, it says we can use what? Letters, digits, and underscore. Okay. But you don't use the numbers, which are the digits. We don't use them at the beginning of your variable name. So you can't say, for instance, first name, you don't go and type first as in one ST and then name. Okay. So this is wrong because of one. We are starting with the number one. Okay, so that makes it an error. So this will be wrong. Okay, so you don't start with a number. Okay. So now let's look at some of the rules with variable names. Let's look at some of the rules. Okay, with writing your variable names or identifier. So first and foremost, it says here that C++ is case sensitive. If we say a programming language is case sensitive, it means that when you are writing your variable name, okay, for instance, capital X is not the same as small x, okay? Or you write a variable name age, you are writing a program to handle the age of people. Age is not the same as age with capital A. Okay, these are two different variables. Okay, so you realize that, I don't know if some of you encountered this problem last week when you were writing the program. You realize that when you write a variable and you want to repeat it again, make sure the same case you use to represent that variable, you maintain that same case name for it when you want to reference it. Okay, but changing it, making maybe the A a capital A gives you an error in your code. Making this capital A will give you an error. Okay, so if you are maintaining maybe small x throughout, make sure you maintain small x for that particular variable. If it's capital X, you maintain capital X throughout. Okay. Then your variable name should not be so long. Okay, it should not be so long. Then also, the initial character must not begin or cannot begin with a digit. I've explained that. And then this one also says you do not use reserved words. Okay, avoid using reserved words as identifier. So we just talked about reserved words. Okay, so reserved words, for instance, you want to declare a variable, maybe the variable is a constant variable. Okay, and you go and write the word, a variable name const. Okay, where we know that const is already a keyword. Const is a keyword. Okay, const is a keyword. If we go back to the back page of the learning notes, we can see here, where is it? We can see const here. Okay, it's a keyword. So you do not use any of these keywords listed here as your identifier or variable name in the program. Okay, you do not use them as an identifier or variable name in your program. Please, are you all with me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right.
No, sir.
No, sir.
Yes, sir.
Okay, so let's move
Yes, sir.
on.
I'm not getting it.
All right. So don't use the reserved words or keywords as identifiers. Okay, don't use them as identifiers. They are reserved words. They have a special role they play in your program. Okay. Then we also have what we call runtime libraries. Example of this runtime library is the assignment I gave you from our last Zoom session, where you were supposed to go and look out for functions, or sorry, libraries, and there are 10 libraries and 10 respective functions in those libraries. Okay, so anytime you have those libraries, for instance, maths.h, okay, which has a function in there as log. You want to find the log of a number. You don't use this as an identifier. Don't use it as an identifier. Another example is IOStream. Okay, you don't use IOStream as identifier. If you've done the assignment, the try assignment, I believe you have a list of functions in there and some of the libraries. You don't use them as identifiers. Okay. Then the other one has to, or the last one has to do with what we call the macro names. Macro names. Okay, I think we'll see some example as we go along. So macro names, usually you define them when you are introducing, you define them outside your main function. Okay, so for instance, this macro name over here, if we go to the programming example we saw here, if you go to this example, you define your macro names over here. Okay, so hash define, and then you say maybe pi. So we know the value of pi as 3.14. So what you've done is you define a macro which is pi. Okay, that means that this word pi, you can't use it as a keyword. Sorry, you can't use it as an identifier in your program after you've already defined it here. What it means is that you can't go into your program and say int pi. Okay, if you do this in your program, it will give you an error because you've already defined it here. Okay, so that is how that also works. Okay, so those are some of the basic rules of identifiers. Some of these things, as we start writing programs, every now and then you get used to them. Okay, some of these things too is when you write your code and you have an error, it makes it easier for you to appreciate some of this error in your program. Okay. All right, so let's look at data types. Okay, so I believe you've watched the video already. So I'm just going through this quickly because the video explains into details these things. Okay, so data types. Okay, so basically, programming has to do with data. Okay, anytime you're writing a program, you make use of data. Okay, and data can come in so many forms. Data can come in so many different forms. Okay, Wise, stop writing on the screen, Wise. Data can come in so many forms. Okay, so for instance, you want to write a program that prints out the name of someone. The name of the person is data. We want a program to display the age of someone. The person's age is data. Okay, so data comes in so many forms. Now, in programming, what happens is that you need to categorize this data in order to use them. Okay, and these categories are what we call the data types. Okay, so a data type is a set of values together with their with a set of operations. Okay, so they fall in categories. Now we group them into 3 over here. So there's a simple data type. In other books, this simple data type is also known as what we call primitive. Bani Bedu, please stop writing on the screen. Sorry, let me type it well. Primitive. Primitive or the primary data types. They are the simple ones. Okay, then the structured data types are also known as the secondary data types. Okay, so mainly for every programming language, they are divided into 2. Okay, but C++ uses what we call pointers. Okay, which you'll come to in the latter part of this course. Okay, so for now, I want us to Desmond, stop writing on the screen. So for now, I want us to look at the primitive ones, okay? The primitive or the simple data types. For the structured data type, we'll talk about one of them this semester, which is what we call array, okay? But for now, our focus is on the primitive data type or the simple data type, okay? Now, why do we say they are primitive? They are primitive because, or they are simple because they form the building block, okay, for every program. For instance, every simple program, if it's going to accept inputs, the input will come in the form of a number or a text, okay? Basically, it will come in the form of a number, a text, or what we also call a Boolean value. Boolean value is a true or false value, okay? So when it comes in a form of number, which is numeric, we say integers, okay? And we use the data type int. So integers are basically positive or negative whole numbers. Positive or negative whole numbers. Okay, so anytime we have them, we use the data type int. Now it has a range. We will not go into that for now. Okay. Then we have what we call the real numbers, also known as floating point numbers. Okay, so these floating point numbers basically are decimal numbers. Okay, so in the numeric, there are 2 forms. We have the integers and then we have the decimal numbers. So the decimal numbers use this data type. So there's floats, there's double, there's long double, and so on. Okay. So anytime you have a decimal number, you can use floats or you can use double. Okay. The only difference between the use of float and double is the precision. We talk about precision, we are looking at the values after the decimal point. Okay, so if you have a value which has a lot of, after the decimal point, you have more than, say, 6 numbers, okay, after the decimal point, then it's advisable you use double. Okay. So they all have their significances and when we use them. Okay, but you can use double, you can use floats. It doesn't matter once it's a decimal value. However, the precision may affect which one to use and as and when. Okay. Then from there we come to so those are the numeric ones. We come to the character data types. Okay, so the character ones, we have what we call char. Okay, we use char or car, depending on how you want to pronounce it. Now, these character data types are denoted by a single quotation mark. Okay, so A is a character, B is a character, 1 can also be a character. Okay, now this one is the digit 1. Okay, so if you write 1 and you put a single quote around it, it's no longer a number, rather it is a character. If I write A in this form with a single quote, this A is a character. If I write 2 and I put a single quote here, this 2 is a character, it's no longer a number. Okay, the same applies to the symbols and so on. So they are represented by the single quote. Okay. And we have a string. So a string is a combination of more than one character. Okay, a string is a combination of more than one character. And anytime we are writing a string, we use a double quote. So for instance, your name is a string. Okay, so let's take a name here. Let's say Darlington. Darlington is a string. Why? Because it's a combination of characters. So how many characters can we see in the word Darlington? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters. So the name Darlington is a string. Why? Because we are combining 10 characters or 10 letters, okay, to make it a string. Then we have Boolean. Now take note, a space, okay, can be also part of a character. So for instance, if I write maybe a name, say Joe King, and I put it in this double quote, okay, this here is a string, okay, including the space between the two words. Okay, it makes it a string. Why? Because of the double quotes we have here, just like you can see over here as well. Okay, and then finally we have the Boolean type, which is bool. So it's used for decision making. So that will give you a response of true or false. Okay, so these are the data types, the primary data types or the primitive data types we have in C++ programming. You should know them and when to use them and the values that can be assigned to them. Okay, so you can't use string and go and assign a character value. No, it should be a combination of characters. Okay, you can't use bool and go and assign a string value to it. It will give you an error. Okay, it's like you saying in English, you say the tenses. Okay, so you are saying that I am. Okay, then instead of saying I am, you say I are. Okay, that's a grammatical error. So in terms of programming, it's a syntax error. Okay, it's going to give you a syntax error because you are not following the rules of the C++ programming in terms of the use of data types. Okay. All right. I see some hands up. Let's take some few questions, about 5 questions, and then we go on. So the first hand I see here is it Awenam or
No.
Awenam? Is that how you spell your Awenam?
Yes, sir.
Okay. All right, let's go.
Sir, please, I wanted to ask whether if you are writing a string, is it
Yes.
like, can you use like a single quote or it's always supposed to be double quotes?
All right, so that's a good question. So in C++ programming, it's always a double quote. Okay, but there are other programming languages where the characters and the strings take single quotes. A language like MATLAB, a language like Python, okay, it takes a single quote. But with C++, anytime you are writing a string, it should be a double quote.
Okay.
All right, so let's take the next question. Christian, Ofe. Christian. Yes, Christian, unmute and then ask your question.
Oh, okay. So I was asking if writing a string, you can write like Daco plus 1, 2, 4. Is it accepted?
A string as what?
Like you write Daco plus 1, 2, 4. Then you bring the two quotation. Is it
Yes,
accepted?
it's accepted. It's accepted.
Oh,
It's a string.
oh, okay.
Yeah, it's a string.
Oh,
Once you have the characters, okay, in the form of the number and the digits inside the double quote, it's accepted. It's like maybe someone is a chief. Okay, so maybe Togbe something something or Nana something something the fourth, where you put IV over there. Okay, once you put that inside your double quotes, it makes it a string, so it's accepted. Yeah.
oh, okay. Thank you.
All right. Okay, let's go to Rosemary.
Sir,
Yeah.
please, so I was asking that with the string, if we have this double quote and then it's only one letter in, is it still a string?
Yes, it's still a string. It's still a string, but
what?
More advisably, once it's one letter, make it a character. Okay, but so maybe you have A and you do something like this. Okay, it's also a string. It's also a string. Now, the other thing, there's this example. I think we'll look at it in our next, maybe our next 2 topics, which has to do with the if-else statement, writing programs on an if-else statement. So we look at something regarding grading of students. So someone having A plus, A, B plus, and so on. Okay, so in this context, because if you want to capture the grades and you use char or car, what will happen is that this one wouldn't work for A plus because A plus is having more than 2 characters. Okay, so rather you have to make it a double quote to make it a string. Now, because we are capturing grade, okay, in its entirety, you need to make the A also a string. The B plus will also be a string as well as your B. also being a string. So you can see here that the A we have here is just one character. B is also just one character, but we are still making it a string. Okay, because we declare the entire grade as a string.
It's true.
Okay. You get it?
Yes, sir.
All right. Thank you.
Okay.
Thank you. Okay, let's take the next question. So 2 more questions, then we continue. So Eric Odro.
So thank you for the opportunity.
Yeah.
My question is on the identifiers.
Okay.
It said that when writing the identifier, the legal identifiers, if let's say you're having 2 words, we shouldn't, leave a space between them.
Yes.
Yeah, and I saw that something like the P reads, that maybe the second word can begin with a capital letter. So what happens if the first word also begins with a capital letter, but the second word begins with a small letter? What about that one? Will
Okay,
it be an error?
there's nothing wrong with that. Okay, so like I've just typed, there's nothing wrong with it, but advisably, the first letter should always start with a small letter. Okay, yeah, it should start with a small letter. So it's something you are advised to do, but make sure you don't leave a space between them like I've done in this case. This is wrong. And also don't use a dot. Don't use don't put a dot there. If you use a dot, it's also wrong. So the only symbol when you're writing your identifier, the only symbol that is accepted is the underscore.
Underscore.
Yeah. If you don't want to use the underscore, then make sure you have the 2 words together. Okay. So this reminds me, there was this year they were writing exams, and in Java, what you do is you create a project and then you give it a name, okay, a class name. And this person, I'm sure, it doesn't even come to class, so he doesn't know that the class names and so on are identifiers. So he typed the class name and was adding space to it and press enter, but the code wasn't working. And this person has sat in the exams or practical for over 30 minutes and is claiming that the PC is not working, the machine or the software is not working. Why? Because he's placing a space between the class name, the variable, the identifier. And because of that, the program is not giving him the opportunity to move to the next stage for over 30 minutes. And the lab technicians also, I think, thought there was an error with it. So it was when I got there, I noticed, this person doesn't come to class, because this is one of the first things I'll teach you when writing a program or when writing a Java program. So until he added the 2 words together, then the application now gave him the opportunity to move to the next stage to write the code itself. Okay, so these are the basics, the fundamentals. So pay attention to it. And like I said, these things come with practice. As you are practicing, you get to know some of these dynamics in writing your variable names and then writing your program. Yeah. So let's take the last question from Bosmatic. I'm not allowing you to ask your question because you are supposed to give us your name, your full name. If not,
okay, sir. My name is Gideon.
No, go back and rename yourself. Okay. Before I'll allow you to answer the question.
Okay.
That's the rule. Okay. I don't have this name as Bosmatic in my on your attendance sheet. So if even I'm marking attendance, I'll consider you absent. All right, let me take the last one from Kelvin Grant, and then we move on.
Sir,
Yes.
I want to write. You write an example of a Boolean statement.
Example of what? A Boolean statement.
Boolean type, like type.
Boolean type.
Will you add? Yeah.
So a typical example is like you saying, let me just try something here. So Boolean type, you say bool, maybe let's say, what word can we use? Let me look for a variable. So bool, let's say decision, sorry. Let me write it here instead. So bool decision equals true. Okay. So you want to make a decision. This decision here is a variable name. Decision is a variable name. This is the data type, and this is the value, true. Okay. So this is your value. This is.
Please, can you add string to the true?
No. Okay, so you don't add. It says true is not a string. It is a Boolean value. That's the value. Okay. So this is the data type. And then you have your identifier or your variable name. Okay, you're welcome. All right. So let's continue. We'll come back for the last set of questions. All right, so let's look at operators. Okay, very, very key in writing your program. Operators. Bosmatic, you've still not renamed yourself. I see some hands up in the chat. Okay, but what?
Please, I've done
Is
it.
it Evander? Why are you showing the middle finger? Are you raising your hands or you are showing the middle finger? Please, let's be careful of some of the things we do. Okay. All right. So let's look at arithmetic operators. Okay, so arithmetic operators are the basic operators that we know in mathematics. So we have addition, subtraction, multiplication, division, and then mode. So we use percentage to represent mode. Modular arithmetic, we use percentage. Okay, so anytime you see this symbol in your C++ program, it means you want to calculate the modulus or the remainder mode. Okay. Now, these operators, okay, addition, subtraction, multiplication, and all that can be used with integers or floating point numbers. Okay, it doesn't matter which values you are working with, but they have to be numeric values. Okay, you can't go and do subtraction. You are subtracting a string from a string. You can't subtract a name from maybe another name. Okay, but what you do is you use these operators, these arithmetic operators, we use them on numeric values. or numbers. Okay, so basically there are 5 of them. Okay? Now, the operators have what we call operands. Operands. Okay, operands. Now you can see some examples here of how we use the operators for arithmetic expression. So over here we have -5. Here we have 3 plus 4. Here we have 3 plus 2 plus 3 times 5. Here we have 5.6 plus 6.2 times 3. And then here we have x plus 2 times 5 plus 6 divided by y. Okay, so these are all arithmetic expression. And you can see x being used here. So in this case, x is a variable. Y here is also a variable. 2, 5, 2, 5, 6 are constants. 5.6 is a constant. 6.2 is a constant value. You know variables and constants already. These are terms that you know from mathematics. Okay. Now, we have what we call the unary operators. So these are operators which have only one operand. Okay, what is an operand? An operand is the value, okay, operands are constants or variables. Okay, operands are constants or variable, and they are joined by operators. Okay, so 3 and 4 are operands, 2, 3, and 5 are operands. Okay, so unary operator is an operator that has only one operand. So example, -5 is a unary operator because it has only one operand, which is 5. Okay, then we have what we call the binary operators, bi for 2. So binary, they have 2 operands. Okay, so this this is a binary expression because it has 2 expressions. Okay, so the operators that hold, there are operators that take only one operand, and there are operators that take 2 or more operands. Okay, so unary operator example is when you have positive maybe 2 or -2. Okay, the positive here and the negation here are unary operators. Then the binary operators, let's say you have 2 times 2. You have, let's say, 2 plus 2. So all the arithmetic operators are binary operators. So let's say you have 2 more 2. Okay, these are all examples of unary and binary operators. All right. Then we come to the expressions. Okay, so let me talk about this operator precedence very quickly. There's this slide that I always use to explain this. Let me see if I can locate it quickly, and then I'll share it with you on the LMS as well. Just a minute, let me locate it.
This is like
Okay, so while I'm searching for it, let me take some questions. So what's the name? Gaffer.
Yes, sir.
Gaffer, please rename yourself and then I'll allow you to ask your question.
Oh, okay, sir.
So Moses Opuni, if you are here, you can ask your question.
Yes, sir. Please,
Yeah.
yeah, I want to ask question about the string. You say if you have in space, space is also a string. So if I have, for example, double quoted space and another double quoted, is that one to a string?
Yes, it's a string. So you have double quotes with a space. It's a string.
Yes.
Yes. So you
Okay,
notice
sir.
going forward, you write programs to give space between maybe names or statements and so on. And we can do it in this form. Or maybe a typical example is maybe you are logging on into a platform where you don't need a password. Okay, so when you get to the password part, what you do is that you make the string open. Okay, you don't put any text
sir.
there, leave a space, then you can log into the password. Yeah.
Okay, sir. Thank you.
Okay. Yeah, you're welcome. Ahitofila.
Sir, please, I want to ask about the urinary and the
Binary.
example, the binary.
Okay.
The C, D, and the E, are they also binary operators?
Yes. So what it means here is that the plus here is a binary operator because it has 2 to the left and 3 to the right. The multiplication here is also a binary operator because it has 3 to the left and then 5 to the right. Okay. So that's what we term as unary and binary operators. Yeah.
Okay, thank you, sir.
You're welcome. Gideon.
Sir, please, I have two questions.
Okay.
My first question is, how do we separate characters and then strings? Maybe on the same line, you want to use maybe two strings on the same line, or it's not possible like that. And my second question is it compulsory we always add operators to a single operand?
Is it compulsory we do what?
We add operators to a single operand.
We add operators to a single operand.
Yes, please.
It's not like it's compulsory. That is the rule. It's like you are doing mathematics and you have -5. Let's say 5 minus -5, right? The -5 here is a negative integer. It's a negative whole number. Okay, whereas this minus here is trying to say that subtract 5 or -5. You get it? So it's not like we are adding it on our own, but it is a rule. You can have values that are negative values. Okay, so if a value is a negative value, we call this negation value here, we call it a unary operator, which is this one. And then the 5 is the operand. Okay.
Okay.
Yeah. All right. I've still not located the file, but I'll still go ahead with it. Let me search for it here. I'll search for it. I'll make sure I get the document and share with you. Dave, don't write on the screen. So let's say operator precedence. Operator precedence in programming. image. Yes, I think it's this image. All right. Okay, so I'll explain this quickly and then we'll bring the class to an end. I hope you can all see this.
Yes, please.
Yes, sir.
Yes, sir.
Okay. All right. So we have what we
Yes.
call operator precedence and associativity. TVT, yeah. Operator precedence and associativity. Okay. Now, what is operator precedence? I believe we've all heard of this word before. Board mass.
Yes. Yes, sir.
Yes, sir.
Right?
Yes, sir.
Has anyone also heard of this before? PEMDAS.
No.
Yes, sir.
No, sir.
PEMDAS.
Yes.
Who has heard
No,
of
sir.
PEMDAS before?
No, sir.
Sir,
Can you
I've
tell
heard
us
of
what
it before.
No,
PEMDAS
sir.
is?
Yes, sir. We heard of
Okay.
that.
So with the
Okay,
You,
let me
you are.
mute you all first. So, Eric Odro, tell us what PEMDAS is. You said you've heard of it before. Unmute and then tell us.
okay, so with the PEMDAS, the P stands for parenthesis,
Okay.
and the E stands for, I think, exclamation, M stands for multiplication, D
The
division.
E stands for what?
Is it exclamation something?
Hey, okay, you go on.
The M stands for multiplication, D division, E addition, and the S subtraction.
Okay, all right, thank you. So E is exponent. E is exponent. All right, so those who are used to board mass, who can tell me what board mass is?
Bracket,
One
bracket.
person.
Get of
Okay.
division,
All
Brackets
right.
of division, multiplication, addition, and subtraction.
And subtraction.
All right, Rosemary, please tell us.
Brackets of division, multiplication, addition, and subtraction.
Hey, Rosemary, who are you there with?
Lily.
You are
She's there
learning
with Dave.
together. Okay.
Yes. Yes,
So
sir.
please start again, Rosemary. I need just one person to speak.
Brackets of division, multiplication, addition, and subtraction.
Okay, what is this of? What does it mean? What is it doing there?
Of is multiplication.
How is this different from the M here?
This one, it has the asterisk, so.
Yeah, but that one doesn't have.
I'm sure it has the asterisk.
Yes.
The O.
Okay, so the O there means
Please, the O means
The O means-
multiplication in a bracket.
All right, thank you, Bismarck. But the O there means order. Okay, the O there is not multiplication. It means order. Now, what does this order mean? It's the same as Eric's explanation to the PEMDAS exponent. So exponent, so let's say 10 to the power 2. This 2 here is exponent. Okay, so that is what we use as order in the board mass. Okay, now in programming, we do not use board mass, neither do we use PEMDAS, because if you get to a point in your program, let's say someone is doing 2 times 2 divided by 2. If the person is using board mass, that person will say that, oh, I'm doing division first, right? Because division comes before multiplication. If another is using PEMDAS, the person will claim what he or she will do multiplication first before division. Okay. Now, operator precedence simply means that every operator has a priority. Okay, every operator in programming has a priority. So this table you see here is a priority of the operators. Now it's in descending order. So that means the higher the higher categories here are operators with higher priorities. Okay, so you can see over here, the brackets, the square brackets or the parentheses are all of a higher precedence. So maybe I can just number it, let's say 1, 2, 3, 4, 5, 6, okay, all the way down. Okay. Now, the next one are the unary operators. They are also of higher priority. Okay, but our emphasis here is on the arithmetic operators. Okay, so with the arithmetic operators, definitely you have an expression which comes with a bracket. Okay, then followed by the exponent. Okay, exponentiation. So values which comes in the form of exponents, maybe raised to the power this, raised to the power that. Then the third is when you have multiplication, division, and then modulus. Multiplication, division, and modulus. They are the third. We are looking at the basic operators, that's the arithmetic operators. Then followed by addition and then subtraction. Okay, so every program, or this is how basic computations are done in programming. It doesn't use board mass, neither does it use PEMDAS, but it uses what we call operator precedence and associativity. Now you see some of these operators, shift operators, relational operators, which we looked at in algorithm, equality operators, bitwise and, or, and not operators, and so on. Okay, they all have their what we call the precedence. Okay, now so that is the order in which the program will deal with operators in an expression, in a mathematical expression. Okay, now someone will say, so what happens when you have operators of the same, you have an expression with the same operators in it, like we have here. So we have multiplication, we have division, and now we are saying that multiplication and division are of the same precedence. What happens is that when you have two expressions, when you have expression with operators of the same precedence in it, like we have here in the 2 times 2 divided by 2. we use what we call operator associativity. Okay, operator associativity. Now, what is this operator associativity? Operator associativity simply means that, or is simply showing you where your calculation should start from. Now, there are two types. There's the left to right associativity, and then there's the right to left associativity. Okay, now left to right means that anytime you have an operator, operators of the same precedence in your expression, you do it from left all the way to the right. Left to the right, okay? Then right to left means that you do it from your right. You start from your right all the way to the left, okay? Now, the arithmetic operators, we can see here, the postfix is part, which has the brackets, the multiplicative, and then the additive, okay? You can see them over here. What they all do is they use the left to right associativity, okay? They use the left to right associativity. That's the basic arithmetic operators. All the arithmetic operators we have here, they are left to right. So if you take the expression which says 2 times 2 divided by 2, what it means is that the computer is going to, or the compiler will do 2 times 2 first, which will give you 4. And then divide it by 2, which will give us what? 2. Okay. Similarly, if the expression were to be in this case where you have 2 divided by 2 times 2, what it will do, it will still do the left to right. So left to right means that it's going to do 2 divided by 2, which is 1, times 2, which is equal to 2. Okay, so that is what we call operator precedence and associativity. Okay, so we'll be seeing a lot of this in our programs. I believe you did some expressions with the codes you wrote last week. Okay, but we'll go more into it. So you need to understand these operators and how they really work in your program. Okay. So for instance, if you have an expression that says 2 divided by 2 raised to the power 4, what it means is that because exponents, the exponentiation, okay, has a higher precedence than the division, you are going to do 2 raised to the power 4 first. Okay, so 2 raised to the power 4 will give us what? 16. Okay. Then 16, or you now do 2 divided by 16 to get your final answer. Okay. So that's what it means by operator precedence and associativity. Any question? I have this image I want to show to you, and then we'll end the class. But if there are any questions, you can raise your hand, and then we ask. I'm sure this image will clear all the doubts that some of you have. Yes, Richard, your hand is up. You can go on with your question.
Okay, so first I wanted to ask, like if you are using, like you won't know the maybe you are using the secondary data type or the primary data type. How will you know that you are using that data type?
Oh, I've told you already. Our focus now is on the primary data type. So anywhere you see int, float, char, double, and so on, string, it means you are using the primary data type. Or basically, if your data has to do with numbers, characters, and true or false value, you are using the Boolean, sorry, you are using the primary, secondary data type.
Okay, thank you.
Yeah, okay. Timothy.
Yes, sir, good evening.
Yeah. Good evening.
Sir, please, my question is, can we get the video before Saturday?
Yes, hopefully I'll try and do that for you.
And my second question is, we all don't have the handout. A lot of us don't have it, so we will still need some.
Yeah, so speak to your class reps. They know how to get copies. So just communicate with the class rep. They'll speak to the
But sir,
TAs.
since we are not in campus, how are we going to get it, please?
So you can always come to campus. The TAs are around. Myself, I'm on campus some of the days. So you can always get it anytime you want to come to campus. Yeah.
All right, sir. Thank you.
All right. Okay. Let me take the last two questions. Bashiru and then followed by
But the phone is there.
Bashiru and then Bashiru, you can ask your question. Then Peter will be next.
Okay, sir. Good evening. I wanted to ask.
Good evening.
I wanted to do the strings compile.
Do the string compile? Okay.
Yeah. When you want to run, when you want to run your code.
Your program. Okay, so I want to assume you are asking this question based on the fact that strings looks like comments, right? Is that the basis on which you're asking this question?
Yes, please. Yes, please.
Okay, so yes, we write strings. Our comments looks like we are writing a sentence. And at the same time, strings are also like we are writing sentence. However, the strings have the double quotes. Okay, so the strings are part of the program construct. So they would definitely be compiled. Okay, anytime we are writing comments, we use a double /. So the compiler sees them as comments, so it won't compile them. But the string, we use the double quotes. So the program or your algorithm, or your compiler will compile the strings. Okay. Let me take the last question from Peter.
Yes, sir. Please,
good evening.
Sir, please, my question is about operators.
Okay.
Let's assume you are writing a program then maybe you assign a number to a variable, maybe A, B, C, and then using one operator, maybe let's say add on maybe A plus B plus C, but with the same one operator which is plus. So that one will only fall under unary or binary operator using our.
Can you repeat yourself again? You said you have what?
Yes, maybe you are writing a program and then you assign a particular number to a variable. Maybe variable A, B, C. And then
variable A, B, and C.
B and C.
Okay.
So maybe you assign a number to A and B and C as well.
Okay.
So maybe you want to find a value of maybe A plus B plus C. A plus B plus C using the same operator which is plus.
Yes.
Yeah. So for this operator plus, you see plus after 32 times. So for the operators, will it fall under unary or binary operators?
So this is binary. Okay. So just see the unary operator like this is binary. Okay, this is binary. Unary operator is like you have a number, maybe -5. Okay, so this negative here is what we call the unary operator. It's as simple as that. Okay, so you can say maybe A is equal to 4, B is equal to -5, C is equal to 2. So in this expression, you say 4 plus into brackets -5. Do you get it? Plus what? 2. Okay, so this plus we have here, this plus and plus here, they are binary operators, but this -5 is unary. Okay, because it has only one operand. All right, so do you see this expression here? Do you see the calculator on your screen, everyone?
Yes, sir.
You can see that the values are different.
Yes, sir. Yes, sir.
Okay, so one is a Casio calculator, and the other is the calculator on your Android phone or your smartphone. Okay, now it's performing the operation 6 divided by 2 into brackets 2 plus 1, and it's giving us 1. Okay, whereas this is saying 6 divided by 2 into brackets 2 plus 1, which is also giving us what? 9. Okay, so this is Casio calculator, but our computer program runs in this form. Okay, why do I say that? In this instance, Umar, please mute yourself. In this instance, what it's going to do is what? 6 divided by 2. Okay, or first it will do the bracket first, which is what? 6 divided by 2, okay, into bracket 3, right? Then it's going to do 6, 2 times 3, okay? So this will be 6 divided by 6, which will give us 1, okay? Now when we come to this Android calculator here, which works more like our C++ program, or works more like the compiler, because this was developed in that instance. What it's going to do is you still have your 6 divided by 2, okay, bracket first, so it's going to do the bracket 3. Now what is happening is it is seeing this bracket as multiplication, okay? So it means that 6 divided by 2 times 3. Okay, so in this context, what will happen is that it will use the left to right associativity, because multiplication, division and multiplication are of the same precedence. So it's going to do 6 divided by 2 first, which will give us what? 3 times this 3 here, which will give us 9. Okay, so even though there are 2 expressions here, this is how the computer works. Okay, this is how the computer works. So mostly, if you are writing this expression on your computer, it will require that there will be an operator in between your 2 and then the bracket. Okay, else some compilers will give you error. Okay, so this image here is just to differentiate between operator precedence and associativity when it comes to some of the things we know already in mathematics, and then trying to translate them, or trying to translate these expressions into programming. Okay, so please take note of that. All right, so I'd like to end here. for today. I have another meeting at 7. So I'll plead with you, if you have any questions, kindly reserve it for our next meeting, God willing, next week, so that we can discuss them thoroughly. Okay.